Hi Ariman, here's your recap video for the last two lessons. So let's have a look at the questions and then we'll take it from there. Okay, so the first one was this question 3 from last Wednesday. And I got you to have a go at that. So I'll just briefly talk about how you do it, just as a reminder. So find dy by dx when parts 1 and 2. So you know the answer to this already before I even asked the question, but what kind of functions are they? Yeah, composite. So we're going to use the chain rule or differentiation by substitution. So we're going to be differentiating 5x minus 2, which is 5, and then differentiating log x, which is 1 over x. So we get 5 over 5x minus 2. The second one, sine 2x, that's just going to become 2 cos 2x. For part B, talking of these two functions, it then carries on, and you need to find the range of f. So remember, range is for all the possible y values. So as x is positive, sorry, x is more than or equal to a half, then log of, if x was a half, then we get 5 halves, which is 2.5 minus 2. So that's a half. So log of a half is the minimum value that y or f of x can take, and then the highest value is just infinity. Find the expression for g f of x. So here we're going to put f of x into g of x, g of f, that reads. So we're going to put, it's going to be sine 2 log 5x minus 2. So let's just find that page. I had it a minute ago. Nope. Can't find it now. I'll just explain it. Yeah, so it's just going to become, that's it really, isn't it? Find expression for that, so it's going to be g of f, put f in g, so sine 2 log 5x minus 2, that's it, a mark. Solve the equation, so equate to 0, so I think that's what I'm writing there. So sine 2 log all that stuff equals 0, that implies that where did I write this thing? I thought I had it all prepared for you. I just thought, I'll go over what we've done. Let me just write it fresh. That's easiest, isn't it? So let's just go fresh. Look at it. Yeah, so the g of f is going to be sine. I'm sorry, also the mouse I've got is even worse than normal. So sine 2, and then we're replacing x with log 5x minus 2. This is why I don't want to write tonight, because my mouse is awful. Okay, and that equals 0. Right. So where does sine of something equal 0, or sine of 2 or something equal 0? And the answer is 0, pi, 2 pi, and so on. So that means that log of 5x minus 2 must be 0. So we just write that, log of 5x minus 2 equals 0, which I think is what I actually wrote on the other page. So instead of writing that again, I'm just going to be very, very cheaty and just do that. That must be 0. If log of 5x minus 2 is 0, then what? Well, we can raise both sides to the power e. Sorry, other way around. E gets raised. I can't remember the terminology, but we're going to have e to the log 5x minus 2 equals e to the 0. E to the log 5x minus 2. Whoa. Told you about that rubbish mouse, I just did that. e to the log 5x minus 2, the e and the log are going to cancel out because they're the opposite type of function. So that gives us just 5x minus 2, and on the right hand side, e to the 0 is 1. So now we just have a straightforward bit of algebra to do. 5x is 3, x is 3/5. So I'm not going to write that. And that's that one. Okay, so next part of the question, solve that equation. The inverse of g is this, find the inverse of g. G is sine 2x, so can you remember how to do that? Have a think, pause the video, maybe do it yourself. Okay, so here we're going to do y equals sine 2x, and then just alter x and y around. So y equals sine 2x becomes x equals sine 2y, and then make y the subject. So to do that, we're going to need to take the inverse of sine. So it becomes inverse sine of y is equal to 2x, and then divide by 2. So it's half inverse sine of y. Then we change the letters back again, so y is equal to half inverse sine of x, which I think is what we did. That's other stuff. I think it's there. No, before that. Boom, there we go. Yeah, and I mentioned at the time that talking about it that here we are. Yeah, I've written it there, but I'm not going any further. They're working. Just on the next page there, I mentioned that there's a notational problem, which is that inverse sine looks like reciprocal of sine, which is, oh there we go, half sine inverse sine, half of inverse sine of x. The to the minus 1 means the reciprocal, so minus 1 inside the sine, which is on the function of sine, because remember, sine x is a composite function, so if we just put inverse sine just on the sine part, it's saying do the reverse of sine, so inverse sine on x. It's also known as arc sine x, which is something you might see around. And that's it, isn't it? That's all I asked on that one, inverse of g, so that's it, we found it. So that's that one. Then on the last lesson I got you to do some questions yourself. So we had question 3, 4, 5 on this paper. So again, I'll just quickly run through. Here we've got a function to differentiate, and it's a product of two functions, so funnily enough we're going to use the product rule. From that we get the, of course when we differentiate we're going to get the gradient depending on the value of x. In this case it just says put the value of x as e in there, and find the equation of the tangent to the curve. It's a classic question, find the straight line equation to the of the curve, of the tangent to the curve. So that's what we did, and then that's going to give a straight line equation, so y equals mx plus c, and the gradient was something like 4e squared, and that was now e squared. This tangent intersects the x-axis at the point A, find the exact value of the x-coordinate of the point A. So here it's classic algebra, trying to find out where two lines cross. So where does the equation of this line cross y equals 0? Here it is. We found the gradient was, we found the straight line, sorry, was 4e squared x minus 3e cubed, there you go. And then we're just going to equate that to 0, because y equals 0 with the x-axis, and solve for x. So that's quite easy to do, because it's just going to be x equal to 3e cubed divided by 4e squared, which is just 3/4 e. And we want to leave that as 3/4 e, not as a decimal. Okay, so that was that one. That was question 3. Question 4, I've got you to integrate by parts, so you use the same technique as always here. Really the question you're ever going to sort of stumble on is, because you're just kind of following a process, really the only kind of difficulty they can throw into it is what you choose for u and what you choose for dv. So if you choose u and you differentiate it and it disappears, you know you've made the right choice. So x differentiates to 1, well that makes the integral you're going to do later a lot easier, because the du is going to be the vdu integral, just leaves you with integral of e to the 6x twice. So that's easy, because that's an easy thing to integrate. So that's the whole goal of the whole thing, trying to change a difficult integral into an easy integral. So you might want to have another go at that yourself, just for the practice. Yeah, pause the video, have a go at it, make sure you get the right answer, and then put plus c. Don't forget to put that plus c, okay? I'll come on down and find you. Diagram shows part of the curve of this. Now this one I kind of skim read it when I was doing it, when I was looking for it for you, and I thought it was just integrate it between 2 points, but there's extra thing thrown on, which was not just integrate it, but find the volume of the solid. So here, all that we do is it's like a pi r squared thing. Every y value is going to go around in a circle, so it generates an infinite number of very thin disks, and the radius of those disks basically changes according to the function. So that as it goes towards 1, the bigger the radius will be. So the disks are in the plane of the page, and you need to sort of rotate the page 90 degrees to see these circles. That's what you'd see, like a kind of cylindrical cone, if that makes sense. So the easy way to do that is just pi y squared, just like pi r squared, but pi y squared. So you just square it up, and if you look at the function you're given, it's actually the square root of the one you just integrated. So that means squaring up is going to give us x e to the 6x, which you just integrated, so you know what that is, and then you just need to put in 1 and 0. Well, just put in 1, because 0 is not going to return anything. And you're going to get your answer, and that's it. And it should be something along the lines of pi e squared something something, and then you just need to put what p and q are going to come out as. So again, have a go at that. And an important thing you can do there is just check the answer on the calculator, because you can numerically integrate on the calculator. So get into the habit of doing that even before you do the question, so you know what you're working towards. And then 5, similar sort of thing we had before, of 2 different functions and stating the range and inverse functions and all that kind of thing. Take the range of f, so similar thing, if x is 2.5, we're going to get 5 minus 5. So it's basically f of x is equal more than or equal to 0, because we want the range, which is the y values. Find f of g, so here we're going to put g into f, so it's going to be 2 times 10 over x, so 20 over x minus 5, all square rooted. Solve the equation f of gx equals 5, so equate that to 5 and rearrange. I mean, it's just simple algebra. You're just trying to figure out where f of g of x that you just created crosses the line y equals 5. Usual thing, trying to find out where 2 lines cross. And then the inverse of f is, I don't know why they say that every time on this exam board. Why don't they just say find f of minus 1? It must be because of the notation it looks like the reciprocal, and so they have to use, I think they actually have to explain it to people doing this. Anyway, find the inverse of f. It wouldn't be an x next to it if it wasn't trying to find the inverse. So we're just going to do the same things before. Y equals square root of 2x minus 5, interchange the x and the y, and then rearrange for y, and then only finished, interchange them again. And solve the equation. Inverse of x is 7, so equate what you just got to 7 for y. So here we're trying to figure out where the inverse function crosses the line y equals 7, so yet more algebra, trying to find out where 2 lines cross. And that's it. If you have any questions on that, I don't think there's anything that you particularly have a problem with. It'd just be good for you to practice having a go at them, make sure that you can do them, achieve some fluency, and give you a better chance of remembering these things. Okay, I'll speak to you on Friday night.